Hello dear students. Yes dear students. Am I audible and visible? Shivam, good evening dear. Good evening, good evening. Yes, come on, join the session very fast. Kailas. Good evening, very good evening. Welcome to the Gradeup. Am I audible and visible? Divyanshu, very good evening dear. Sharu, very nice, very nice. Sahil, this is actually session for the mechanical engineers, dear. So some other sessions may be running for this electrical engineering. So dear students, this is the series which is related to the crash course of the mechanical engineering, and we have started the subject production engineering. So dear students, so yesterday we actually started the new topic. कौन सा टॉपिक चालू किया था हमने? Let me know which topic we started. Come on dear student, join this session very fast. Yesterday we have solved some of the very nice questions, and today also we are going to continue same. We are going to keep that momentum alive in this session also. So be there, ask your friends to join the session, share the link, and do follow me on the Gradeup app. When we will get starting classes for GATE 2020, definitely this, if you talk about right now we are focusing for the GATE 2021, but yes, if you want that, definitely very soon we are going to start the classes for 2022 also, right? So dear students, this is about me. I am Onkar, having more than 10 years of experience for teaching GATE and ESE. Till now I have mentored more than 10,000 number of students. My area of expertise are production and industrial engineering, fluid mechanics, mechatronics and robotics as well. So dear students, see, I hope this is a rollover question in the yesterday session. Yesterday we have solved very nice questions, dear students. So I hope be there dear students, okay, till the end. Don't leave in between. This is very important and useful for you guys, right? So let us take this question and start solving. And one of the very important assumption, that what I am assuming, that you are knowing some of the very important and basic formulas related to this subject. Based on this only we have planned this crash course, right? Come on dear students, be there. Kailas, Shivam, okay, please. Yes, so this is the first question in front of you. This is the first question. So my steel is being machined at the cutting speed of 300. Cutting speed is given, we see 300 meter per minute, okay, and the normal rake angle is given as 12 degree. The width of the cut B is given as 3 mm. Then what they have given, the uncut chip thickness, that is T1 is given as 0.25 mm, right? If the average value of coefficient of friction between the tool and the chip is mu is given as 0.5, and shear strength tau s is given as 420 megapascal or Newton per mm square. So they are asking us to calculate the shear angle, cutting and friction force by using the Lee and Schaefer theory. So basically tell me first what is about this Lee and Schaefer theory. Merchant theory, dear students, बोलती है that 2 phi, this is the relation between the shear angle, friction angle and the rake angle. 2 phi plus beta minus alpha, which is equal to 90 degree. But according to the Lee and Schaefer theory, which is based upon the theory of plasticity, which is based on the slip line theory, okay, slip line methodology, based on the ideal plastic deformation, this theory is based, that is EC Lee, EH Lee and BW Schaefer proposed this theory, which gives the result that phi plus beta minus alpha is equal to 45 degree. You know very well, this is the Lee and Schaefer theory. Now we have to use this theory and we have to go for finding out the shear angle, cutting and friction forces, and the, yes, that three things only they are asking. Akhilesh, ask your friends to join the session, dear. So what is here? See, if you are given with the coefficient of friction between the chip and the tool, definitely we can able to calculate the friction angle, because you know that the tan beta is equal to nothing but mu. So tan beta, tan of angle beta, which is the friction angle beta, is equal to 0.5. Tell me how much beta? It is tan inverse of 0.5. What is tan inverse of 0.5? So shift tan inverse of 0.5, it is dear 26.56 degree. Rake angle is how much given? It is given as 12 degree. Any other thing is not available with us, because no any cutting ratio is given, chip thickness ratio is not given, or no any cut chip thickness is given. So definitely we can directly use this Lee and Schaefer theory, which is saying that phi plus beta minus alpha, which is equal to 45 degree. I can easily calculate now the shear angle phi. So I know phi plus beta minus alpha is equal to 45 degree, which is again actually this theory is not have so much importance like this Merchant's theory, because see the same, whatever the result given by the Merchant theory and whatever the results given by the this Lee and Schaefer theory, whatever the trend of the graphs, ultimately values may be the different one, okay, ultimately what we are plotting phi versus this beta minus alpha, whatever the trend that we have obtained for this Merchant analysis and for this Lee and Schaefer analysis, Lee and Schaefer theory, values may be different, but the trend almost same. Trend of this Lee and Schaefer and trend of the Merchants are almost same. So now tell me what is the angle phi here. So phi plus beta is how much? 26.56 minus alpha is how much? 12 is equal to 45 degree. Tell me phi is how much? 30.43 degree. Very nice. See, I am trusting you because I am not calculating. Okay, so live मतलब सब चीजें live होनी चाहिए. Dear students, come on, join in numbers. I hope this is for you only. This is all beneficial to you only. And participate actively with the calculators. Actively participate. Actively have the use of chat box. Please write the values there so that I am also get the charge. Tell me phi is 30.43. Now it is okay. Shear angle मिल गया हमको भाई. Shear angle मिल गया 30.43. Now the cutting and frictional force. Now you know very well relation, dear students, between the cutting force and the shear stress, right? That is FC divided by FS. आपको पता है, जल्दी से बोलो ये क्या है? यूनिवर्सल मशीनबिलिटी इंडेक्स है, isn't it? Which is equal to cos of beta minus alpha divided by cos of phi plus beta minus alpha, which is equal to 45 degree according to the Lee and Schaefer theory. This is what? Cos of 45 degree. Yes or no? And you know very well that the shear force can be determined as the sheared area into the shear stress, which is equal to sheared area, you know, BT1 divided by sin phi. अब मैं लिखता हूँ, बताने की जरूरत नहीं है, into shear strength. So बताइए width of the cut कितना दिया है, which is nothing but the depth of the cut. It is 3 mm. So 3 into what is uncut chip thickness, that is 0.25. 0.25 divided by what is sin of phi, अभी आपने calculate किया 30.43. Into what is the shear strength of the material is given, yes, 420 Newton. per meter millimeter square, 420 Newton per millimeter square. Tell me what is the value of this Fs. Tell what is the value of this Fs. That is 3 into 0.25 into 420 divided by sine of 30.43. I am getting here the value as 622 Newton. Please check it out. 622 Newton. Where you are getting the value of the shear force? 622 Newton मेरा shear force आ रहा है in the cutting operation. Please let me know the value whether it is correct or wrong. And once I get this value, definitely I can easily calculate the FC. What is FC? Now FC I can, that is equal to Fs cos of this beta minus alpha divided by cos of phi plus beta minus alpha. Yes, Aman. Aman, very welcome dear. Okay, so in this case tell me Fs is how much? 622 into cos of beta कितना आया था अपना? बीटा फ्रिक्शन एंगल दिया था ऑलरेडी 26.56 20 oh here it is 5 is how much? 30.43 plus 26.56 minus that is okay. It is beta minus alpha, no? Beta is how much? 26.56 minus alpha is, I hope it is 12. Yes, it is 12 divided by cos of 5 plus beta minus alpha according to Lee and Schafer it is 45. Tell me. That is 26.56 minus 12, which is the cos of this thing, cos of answer, divided by cos of 45 into 622. So I am getting 851.4 I am getting. Check it out 851.4 Newton. This is my cutting. So dear students, one more very important news. On Tuesday and Wednesday I am going to have the planning for to keep 2 hour sessions, especially on the metal forming, okay, which are the very highly weighted topics in the production engineering. I am going to target those topics so that we will get benefited. Okay, starting from the fundamentals of metal forming, which are the question can be asked on this true stress strain, okay, the velocity of deformation, the true strain rates. Starting from that definitely each and every bulk deformation process, including with the sheet metal working, consecutive 2 days on Tuesday and Wednesday in the afternoon 2 to 4 2 days, that is within these 4 hours we are going to go in depth about this metal forming along with the sheet metal working. So do join the sessions Tuesday afternoon 2 to 4 and Wednesday afternoon 2 to 4. Okay, so where in depth, in details we are going to discuss about this metal forming topic. Definitely there are always chances to have 4 to 5 marks from this area, more than that also. So please be there on Tuesday and Wednesday in the afternoon 2 to 4. I hope it is clear. So very nice. 851 अगर FC आ गया तो definitely FT कैसे निकालते हैं आपको पता है. So FT I know yesterday we have solved the question like this, FC into tan of beta minus alpha, isn't it? Yes, definitely. So first targeted topic is metal forming, because see metal cutting just now we have started, or we have spent already 1 hour yesterday, and this is 1 hour 2 hours. So after metal forming, definitely one marathon series on the metal cutting before this December ends I am going to plan. Okay, so we'll start with the forming. sheet metal working, and then definitely the targeted topic is metal cutting. Okay, so in that we are going in depth from the lathe operation, the shaping, milling, drilling, grinding, all the things, taper turning, all the things we are going to discuss, and we are going to solve the questions. Okay, don't worry Shivam, don't worry, we'll get everything. So just I want your presence so that it can be a successful one. Are you with me? Aman, Shivam, Akhilesh, Sharu Iyer, tell me how much this FT? Is it 221 Newton? Please check it out. Yes, Aman, very nice, Akhilesh, Aman, very good. So see, we have solved the question. We already solved this question. So we have calculated the shear angle, we have calculated the cutting force, we have calculated the thrust force. All these things is done, isn't it? Very good, very good. Thank you, Akhilesh. Fine, take the next question. Now it's very simple. Tell me, power consumption in the metal cutting is mainly due to. So in the power consumption, dear students, if you know the FC into VC plus the field force into the field velocity. So actually this part is very negligible. This part is very negligible, you know that. So power generally or work done, we write it as FC into VC. So FC is what? Our main tangential component of force, or this is the cutting force, right? Because if field velocity, if you talk about F3, there are three velocities. It's F1 which is field in mm per tooth. There is F2 which is known as the field in mm per revolution. Okay, and F3 which is nothing but the table field or longitudinal field or table velocity, which is nothing but mm per minute. Okay, so definitely this is in mm per minute, or which is the nothing but product of F2 into the RPM of the spindle. So F2 which is in mm per revolution into this revolution per minute. So that is why it is mm per revolution, sorry, mm per minute. Okay, and if you take this field velocity into account, definitely, so you will be having here, say for example, the F2 is 0.1 mm per revolution, for example I am taking, and you are having the spindle speed of say 600 RPM. So definitely this value Ft into this F3 Ft into this F3 will be definitely is very less, very less. Why? Because see, this Ft is having some value into F2 into N, that is nothing but F3. So Ft is 0.1 which is mm per revolution. I want say in meter, because see work done is what? It should be Newton meter per second, that is say joule per second if I want. So I have to take the value in meter. So into 10 to the power minus 3 into RPM. These are the say 600 revolution per minute. So I have to again take into per seconds. Then I will get this Newton meter per second. So see this product, it will be very negligible. So FC is important for us. So I hope you know this. Yes, very nice. Aman, Shivam, very good. Yathin, yes, very good. A is the correct answer. Take this question, which is based on the Taylor's two life equation. This is this modified two life equation, dear students. That is V t to the power n into the field to the power say P into depth of cut to the power Q is equal to constant, where of course P should be greater than equal to Q, and field F is what? Your field in mm per revolution, and your D is what? The depth of cut in mm. Right? So what they are saying, they have given the generalized Taylor's two life equation or modified two life equation. Taylor's two life equation, V is equal to C upon T to the power 0.3, F to the power 0.6 and T to the power 0.3. A 60-minute tool life was obtained using the following cutting parameters. कौन से cutting parameters है? The cutting velocity is 40 meter per minute, feed is 0.25 millimeter per revolution of course, depth of cut is 2 mm. Compute the tool life if the cutting speed, feed and depth of cut are increased by 25% at one time, and also if they are increased by 25% individually. So what we can get the results. Okay, so please join the session and please participate, dear students. Unless you participate, only seeing is not enough. You should solve with me. So what I can write here, what is the equation given? V is equal to C divided by T to the power 0.13 into F to the power 0.6 into D to the power 0.3. That is, of course, this V into T to the power 0.13 into F to the power 0.6 into D to the power 0.3 is equal to constant. Okay, what are the initial conditions or initial values they have given? They have given that tool life is 60 minutes. When there is a cutting speed, you are using that 40 meter per minute. Okay, you are using the feed as 0.25 mm per revolution, and you are using the depth of cut as 2 mm. Isn't it? Yes or no? Now based on this, if you put this all the values, definitely what you will get? You will get the value of constant C. So put the values here and tell me what is the value of constant C that you can get here. Please tell me. So this 40 into this T is how much? 60 to the 0.13 into feed 0.25 to the power 0.6 into depth of cut 2 into to the power 0.3 is equal to C. Tell me the value of this constant C. Tell me this Taylor's constant C in this equation. Very fast. Come on, dear students. Solve these things. Yes, Akhilesh, tell me the value C is how much? Are you getting this 36.43? Are you getting this 36.43? Okay, and now dear students, go one by one. So all together we are going to apply that there is a rise of 25% in the speed, feed and depth of cut. Okay, at one time. So please check it out, dear. I am getting 36.43. Yatin, Aman, Heart Touch, Shivam, please tell me the values. So C is 36.43. I am getting. Please tell me. Very nice. 36. Very good. 36.43. Okay. Very nice, Aman. Now when I get this value, now if you go by the first condition, what they are saying, that is, if you increase all these parameters like VC by VC, then feed and depth of cut increased by 25%. Okay, by 25%. Tell me what will be the new values of cutting speed, feed and depth of cut. Now VC will be new value. VC will be what? 25% more, that is 1.25 times. Initial value was 40. Tell me that VC. Now feed will be again 1.25 times. Initial value was 0.25 mm per revolution, and depth of cut initial value was 2 mm. So tell me after increase of 25%. So if you increase it by 25%, I will get the cutting speed as 50 meter per minute. I will get the feed as 0.3125 mm per revolution, and I will get depth of cut as this 2.5 mm. Please check it out. These are the new values when you increase these values by 25%. Okay, now just again write the v1 t1 to the power n is equal to v2 t2 to the power n is equal to constant. Now you tell me, if you write like this they are asking what is the effect of all this change onto the tool life. So if I write separately, this t to the power 0.13 is equal to this C, how much C? 36.43 divided by, now new values are what? This velocity is what? 50 into speed to the power nothing, that is 50 into feed is how much? Now new feed 0.3150, new speed we have written, to the power how much? 0.6, and now new depth increased by 25%, it is 2.5 to the power 0.3. Yes, yes. Yes, if you increase by, see, if you increase by 10%, okay, so it will be 1.10. If you increase by 1%, it is 1.01 times you have to increase, isn't it? So that is common aptitude, right? So I can't able to understand your name. It is Imran Khan. Oh ho ho, very nice, Imran. I hope it is clear. So if you now calculate the value of T, that is tool life they are asking, when all together effect of this 25% rise in the cutting speed, the feed and the depth of cut, it will result into the tool life. देखो कहां से कहां गई, इनिशियली टूल लाइफ कितनी थी रे, 60 मिनट थी, अब कितनी आ गई, वेदर इट इज 2.26 शिवम, I am getting answer as, if I solve this very nicely, it will be 2.26 minutes. I hope it is clear. I hope it is clear. Now what they are saying? They are saying that okay, fine, when we are having the combined effect of this 25%, now they are saying individual effect of 25% rise. Okay, where you have to put the value separately for VC after adding 25%, then feed after having 25% increase, then the depth of cut having 25% increase. Yes, 2.3 is correct, Akhilesh. Very good, Akhilesh. Yes, Shivam, very good, very good. Now tell me, if I take, suppose now I will take the first case, only individual matlab what? Only say VC increased by 25%. So what I will get? Only VC increased by 25%, that is our equation becomes T to the power 0.13. All the things except the cutting velocity, which is going to only increase by 25%, all other are the initial values only. So it is 36.43, it is my constant, divided by now only cutting velocity कितनी change हो रही थी भाई? If I increase it from 1.25 times of 40, it will be what? It will be now 50 meter per minute into the rest of thing, the feed will be 0.25 to the power 0.6 into depth of cut was initial only 2 to the power 0.3. Tell me what is the tool life? Individual effect of 25% increase in the cutting speed. क्या आएगा बताओ जल्दी से? How much it is? How much it is? So if you nicely calculate, it will be 10.62 minutes. So देखो ये है इंडिविजुअल इफेक्ट. सबसे पहले अगर टूल लाइफ चेक करो, टूल लाइफ थी अपनी 60 मिनट व्हेन कटिंग स्पीड वाज 40 मीटर पर मिनट. जैसे आपने कटिंग वेलोसिटी बढ़ाई, डेफिनेटली कटिंग वेलोसिटी बढ़ती है तो यहाँ पे टूल लाइफ घटती है, isn't it? So you can see the now effect. You can see as you increase the cutting speed by 25%, the tool life dropped from 60 minutes to directly 10.62 minutes. That is the effect. You know, this is the very important curve, dear student. This is the tool life and this is the cutting velocity. As you increase the cutting velocity, tool life must decrease, definitely. And if you want the very good tool life, you use that tool with the minimum cutting speed. And this is how we have to manage for the optimum cutting speed to get the very good productivity. Very nice, very nice. So individually, second effect is what? Now get feed increased by 25%. Rest of the things are same now. So T to the power 0.13 is equal to, C is how much? 36.43. डिवाइडेड बाय कटिंग स्पीड इनिशियल था उतना ही 40 इंटू नाउ फीड इंक्रीज बाय 25% कितनी आई थी? अभी किसी ने बताया था, अमन ने बताया था 0.3125 टू द पावर 0.6 इंटू डेप्थ ऑफ कट भी पुरानी वाली 2 टू द पावर 0.3. टेल मी व्हाट इज द टूल लाइफ इन दिस सिनारियो? So if you calculate very nicely, I will tell you the value. It is 21.10 minute. Now see, initially whenever there was a feed of, there was how much feed there? 0.25 mm per revolution. Now you increase the feed. Okay, but see, जितना इफेक्ट कटिंग वेलोसिटी आपने चेंज की 25% से, ड्रास्टिकली यू कैन सी 60 मिनट से सीधा 10 मिनट पे, मतलब 6 टाइम डाउनफॉल हो गया टूल लाइफ में. लेकिन उतना डाउनफॉल नहीं है जब आप फीड को 25% इंक्रीज करते हो. ओके, समझ में आ रहा है ना भाई? वेरी गुड. एंड सेम केस इफ यू चेक द डाउनफॉल फॉर व्हेन यू इंक्रीज द डेप्थ ऑफ कट बाय 25%, t to the power 0.13 is equal to 36.43 divided by cutting velocity same 40 into now feed is same 25 to the power 0.6. Now change the depth of cut to the 2.5 mm to the power 0.3. You will get the tool life as 36 minutes. Now from, see, this is not only like the question is there and you want the numerical values and that's it, you will get the mark, but the understanding behind this, what actually data is telling you. Data is telling you that yes dear, when you have the 25% increase in the cutting velocity, definitely it is going to affect the tool life very harshly. Very harshly tool life is going to affect. It is directly coming down to the 10 minute from 60 minute, but less effect you will observe than that when you will having the feed which is increased by 25%. And again very less effect you will observe, again very less effect you will observe when you are having the depth of cut which increase by 25%. see, मतलब 60 मिनट से 36 मिनट पे आया. So not a very huge difference, but dear students, when there is a change in cutting speed by 25%, definitely there is a drastic difference you can see. So that is actually outcome. See, simply solving the question, that is okay, but understanding is also important. How, what actually the problem is trying to tell you. Very nice. Next question. Take the question, solve this. Very good. During orthogonal turning operation by using the high speed steel tool, 25 and 4 pieces are produced at the cutting speed of, what cutting speed was there? 200 rpm and 400 rpm. Okay, the number of pieces produced if the cutting speed of 300 rpm is used. So before solving this question, dear students, there is very important thing. You know that the tool life measure sense we can able to express in terms of the minutes. Okay, but the another senses are also there. Either you can represent this tool life in terms of say number of pieces, or you can also represent the tool life in terms of the material removal that you have achieved for that particular time between two successive regrinds. So here what this actually this problem telling you, the problem is not telling you the tool life in minute. So he will try to tell you the tool life in terms of the number of pieces produced, isn't it? And here instead of giving the cutting velocity, of course it is given as the rpm. You know cutting velocity is pi dn by 1000. Okay, you know very well. So velocity, or if I write in meter per minute, or I can also present in terms of the rpm. Yes, it is possible. Now what is your popular equation? Vt to the power n is equal to constant. You can write in terms of say tool life in number of pieces, okay, and velocity in terms of the rpm. So n into p to the power n is equal to constant. You can write like this, or you can say n1 p1 to the power n is equal to n2 p2 to the power n is equal to constant, isn't it? So here in this question what they are saying n1 is, when n1 is 200 rpm, how many pieces you can produce? So p1 is 25 pieces. And when this n2 is increased to 400 rpm, now we can able to produce only 4 pieces. Okay, so definitely put in the equation and try to find out the Taylor's exponent C. I will write here. So 200 into 25, so 200 into 25 to the power n is equal to 400 into 4 to the power n. Okay, so that will be, I will write 25 by 4 to the power n is equal to 400 divided by 200. That I will be write n ln of say 25 by 4 should be equal to ln of this 2. Tell me what is n value, Taylor's exponents, how much you are getting the Taylor exponents n, Taylor exponent n. Tell me the value of Taylor's exponent n. Yes, anybody is there who is trying to telling me the value of this n? अरे भाई कोई कैलकुलेट कर रहा है कि नहीं? अमन, शिवम, अखिलेश, वरुण त्यागी. Yes, 0.37 or 0.38. Okay, very nice. Check it out whether it is okay. Very nice. 0.38. Okay, Vikrant, 0.38 or 0.37. Okay, whatever it may be. Now what they are saying, okay, the number of pieces, they want to know the number of pieces produced when the cutting speed is now used as 300 rpm. That is, they want the value of p3 when n3 is how much? 300 rpm. So now we can very easily write, so n3 into p3 to the power n is equal to constant. So for that reason you need to calculate the constant now. Okay, once you get this value of c, so put here value of n to get the value of constant c. So here I will write, say 200 into 25 to the power 0.38 is equal to constant c. Tell me what is the value of constant c. So if you see, I am writing the value of constant c as 675. Okay, Akhilesh, that's okay. See, understanding is very important. 0.38 ले लो, 0.37, whatever it may be. You round out to 0.38 is okay. Whether it is 675, again I am not going to the exact values. So I am going to round up some values definitely. I don't want to play in that point this much, okay. So how much it is, 679 or 675? Please tell me. I am getting say 675 is the constancy when I put the value of say 0.73. If you are putting 0.38, definitely it is going to be 679. I hope it is okay. Akhilesh. Yes, answer will be 9 only. Yes. So if you take it as say 679 or 680 rather, okay. So if you put it here, that is n3 number of pieces into p3, that is 300 to the power say 0.38 is equal to constant is what, 675. Definitely you will be getting say n3, sorry. We want the number of pieces, no, the n3 is given. n3 is what, 300 into P3 to the power say 0.38 is equal to constant say 675. So P3 if you calculate nicely it will be around say actually it is coming as 8.97 and which will be rounded off to 9 pieces. So 9, yes, approximately 9. So see here, option A is 6, it is not, 7 is not, yes 9 is there. So 9 pieces, yes 9 pieces. आ गए कि नहीं भाई आंसर? 9 pieces. Akhilesh, why you are thinking if you are getting 9, 8.6 or 9, that is 9. No need to think, you have already calculated. So be confident. Take the next question. This question is already done. Take this question. A component of length 60 mm is to be knurled on the surface. The cutting speed used during operation is 1.5 meter per second. The diameter of the job is 20 mm and feed given is 0.012 mm per revolution. The time required for the operation is, this is the knurling operation is given, knurling. Okay, the diameter is job 20 mm. So you know definitely. So here cutting velocity is nothing but pi dn divided by 1000. You know very well. Okay, but here it is given as 1.5 meter per second. But generally we take it as a meter per minute. You know very well. So I have to multiply by 60. Then it will be 15. 1.5 into 60, it will be meter per minute. It will be meter per minute, isn't it? So it will be 90 meter per minute. 90 meter per minute. That is your cutting velocity. And for calculation of the time, definitely what is formula for time calculation? So time is equal to length of the workpiece divided by F2 into N, or simply you can write L divided by F3. Okay, that this is the length in say mm. Divided by F2, it is in mm per revolution, into N is what? Revolution per minute. So you get here revolution to cancel out, so it will get only in minutes. Time you will get in minute. Okay, now see here, length of the job is how much? Length of the job is how much? It is 60 mm. Okay, N is not there, so definitely cutting velocity is what? Pi dn by 1000. So VC हमने कितना निकाला मीटर पर मिनट में? मीटर पर मिनट में it is 90 into 1000 divided by pi into diameter कितना है जॉब का? 20 mm. Please check it out. So it is equal to your RPM. So tell me how much the RPM you are getting? Tell me how much is the RPM you are getting? So now there is a knurling tool is there. Okay, say knurling tool is there. Okay, and you are going to face this surface. Okay, to get this impression of the knurling onto the surface. Okay, so time N you want to know. The cutting speed is known to you, 90 meter per minute. So diameter is given, it is 20. Okay, and feed for the tool is how much? 0.012 mm per revolution, isn't it? Because knurling करने तो feed तो धीरे धीरे देनी पड़ेगी. Even though cutting speed it is okay, it is very high, but feed you have to give a very little feed so that you can get the very good impressions like this, isn't it? So yes, Vikrant. 1432 N is how much? 1432 revolution per minute. Now calculate the time is equal to what? L divided by F2 into N. So length is how much? 60 divided by feed how much? 0.012 mm per revolution into RPM 1432. Okay, tell me time will be how much? It is 1432.4 something, no? If I take that also, so it will be how much? 3.5 minutes. Yes, 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 of course. Very good, Vikrant. Very good, Shivam. Aman, very good. Tell me the value, Akhilesh. Then who are there? So if you try to convert it into the seconds, it will be 210 seconds. Multiply by 60. So 3.5 minutes is also answer, and the 210 seconds, this is also the answer. Check the answer. Option A 3.5 seconds. No, it is 3.5 minutes. So A cannot be the answer. 210 seconds. Yes, this is the answer. And 3.5 minutes. Yes, this is also answer. And 2.10 minutes. No, it is not answer. So see this question, yaar, ye to multiple select question nikla. Bhai, see, this question now becomes the multiple select question, because see, in seconds 210 is also correct answer, and 3.5 minutes, this is also correct answer. You have to spend 210 seconds. Very slowly you have to give the feed 0.012 mm per revolution. Very nicely you just go and give that feed. You will get the surface knurled. So what is the answer here? Tell me what is the answer. What is the answer here? So B and C are the correct answers here. B and C are the correct options actually. B and C are correct. B and C are correct. Next question. Next question, take this at question here. Take this question here. अरे भाई कोई तो रिप्लाई दो. कोई तो रिप्लाई दो भाई. कोई है कि नहीं वहां पे? So this is the question in front of you. During the machining process, the cutting force induced हाँ, तो ऐसा लाइव चैट बॉक्स तो थोड़ा लाइव रखो ना यार. चैट बॉक्स से ऊपर नीचे होना चाहिए बार बार. Irana, be there. Have some movement in the chat box. Keep it alive. Now see, we are discussing here. We are not just keeping mum or shut here. Okay. So see, during the machining process, the cutting force induced is 1500 Newton at a cutting velocity of 1.8 meter per second. Yes, Giraj, very good. The density and specific heat are 7800 kgs per mm cube and 500 joules per kg per degree centigrade respectively. The feed and depth of cut are 0.5 mm per revolution and 4 mm respectively. If the work carry 15% of heat generated, the expected average rise in the temperature of the chip will be. Please try to solve the question. Yes, yes, see. So what they have given here, see. So you know that, dear students, you know that. So maximum heat carried away by whom? So you know that heat carried away by, सबसे ज्यादा हीट कौन की लेके जाता है भाई? हीट कैरिड अवे बाय चिप, then it is carried away by work, and then it is carried away by tool. And that heat we can definitely equate with the work done. We are equating with the work done, and you know that out of the total heat carried away, okay, there is the work which is going to carry the heat in some of the fractions of the total work done, isn't it? So how much it is carrying out? They are saying work is carrying out the fraction A 15% of the work done. Okay, this is the heat carried away by work, and definitely we are assuming that tool is carrying very less heat, so it is say neglected, you know that. So if I want to write that the heat carried away by chip will be how much? So it will be equal to, so heat carried away by chip plus heat carried away by work. So how much heat carried away by work? It is A times, this is sum of the fraction of the total work done, FC into VC. So here I will write this total work done, so it will go in this side, so become minus this A times this total work done. So heat carried away by the chip will be equal to this work done into bracket 1 minus A, isn't it? This is the heat carried away by chip, this is the heat carried away by chip, isn't it? So if I write here, what is what is work done? Actually we are taking just now in the, okay, so we just see the work done is what? Maximum work done जो होता है power in metal cutting जो consumption होता है, definitely it is because of FC into VC into bracket 1 minus A. A is what? Fraction of heat carried away by the workpiece of the total work done. So this heat carried away by the workpiece, if I write how to calculate heat carried away, that is nothing but M into Cp into delta T, isn't it? Is equal to this FC into VC into bracket 1 minus A. And you know that this delta T, that the thing we are going to calculate here, which is the temperature rise. Temperature rise is there, that is from maximum T maximum in the metal cutting zone minus the room temperature or the ambient temperature. This is the delta T you are going to find out in terms of degree centigrade, isn't it? Yes or no? So tell me, if I write this delta T is equal to this FC into VC into bracket 1 minus A divided by this M into Cp, isn't it? Now dear, what is the mass of the chip? I want to know. Then because I am writing this for the chip, isn't it? And what they are asking, the expected average rise in the temperature of the chip. Okay, so for chip we are writing, so M is what here? The mass of the chip, How we can write the mass of the chip? If you take the chip and measure the weight of the chip, we can get it mass, that is nothing but the volume of chip into density of the material, isn't it? So dear, if you look at here, you know very well, this is the main diagram in the metal cutting. So how much actually, see, this is actually the undeformed chip condition which is there and which is going to cut, right? We are having the cutting velocity here VC, say initially it is having the width of the chip as a width of the workpiece B, right? So if I take here, and what is there, and it is initially it was in the material, so it is uncut form is like this, having the some thickness T1, right? So if I say that the volume of the chip, actually volume, if I write here in terms of say B into T1 into VC, so nothing is wrong there. So this is the volume I can have here for the chip, right? And density of the material is how much? 7800 kgs per meter cube it is given. So if I nicely write here, this mass is nothing but volume into density, and volume is what? My volume is this B into T1 into VC I will get this mass as in terms of this. So if I write it here very nicely, this delta T now becomes delta T is equal to FC into VC into bracket 1 minus A divided by this BT1 B into T1 into VC into rho M into CP. So VC will get cancelled out. So now temperature rise delta T is equal to FC into bracket 1 minus A divided by this B into T1 into this rho M into CP. Put the values here. Cutting force is how much? 1500 Newton into bracket how much fraction of heat is carried away by the workpiece? 15%, that is 0.15 divided by what is the width of cut? It is 4 mm and uncut chip thickness, that is in orthogonal we turning general we take 0.5 mm is what? The uncut chip thickness. So how much it is? So 0. How much? 5 into width of cut say 4 into density of material, and of course these are in millimeters, so definitely density in kgs per meter cube. So I will take these values, these are in millimeters, so into 10 to the power minus 3 into 10 to the power minus 3, so it will be 10 to the power minus 6 into 7800 kgs per meter cube into how much? CP value. CP value is how much? Yes, 500 joules per kg per degree centigrade. Calculate and tell me the answer. Calculate and tell me the value of delta T, temperature rise in degree centigrade. Tell me the value. Yes, come on. So Vikrant, Giriraj, Iranna, Shivam, Aman, Akhilesh, tell me the value of delta T and tell me the answer. Here are the options. Whether it is 63, 100, 129 or 163, please check it out. Very good Shivam, very good Shivam. It is nearly equal to 163 degrees centigrade. Excellent. Any other? Akhilesh, Vikrant, Giriraj. Do the calculation dear. Do the calculations and tell me the answer. Very nice question. This is the question regarding to the heat generation or thermal aspects in the metal cutting. So yes, 163 option D is correct. Aman, very good Aman. Very good Shivam, Aman, I am waiting for the reply from Giriraj and Akhilesh. Yes Akhilesh, very good. 163. That is the answer. So dear students, see, please. Tomorrow we will be having the discussion on the combined discussion on the non-traditional machining, only numericals. So ECM, EDM, very powerful source of the questions from the non-traditional machining to have the numericals. So we are going to see the numericals on the ECM, EDM. Also some of the numericals on the drives in the advanced machining methods, NC, machine tools. We are having the servo motors. We are having the stepper motor. Based on that we are getting some numericals. We are going to discuss those in tomorrow's session. So I hope you will join this session tomorrow again at 7 p.m. Definitely we are going to discuss this. Day after tomorrow on Monday we will be discussing the numericals on the metrology and inspection. And don't forget on Tuesday and Wednesday marathon I am going to run for the metal forming in depth. So be the part of that. Ask your friends to join this session, dear students. Very helpful to you. This is for you only. Right? Take these questions as for the homework. Take this question for the homework. This is done. This is done. I hope. Yes, yes. Take this question for the homework. Very nice question again. Here they are asking to determine the three components of machining forces. कौन से three components? Dear, one is FC, main tangential force, and you know that FT it get divided into two. That is, one is axial component of force, F axial, and one is F that is normal to the machine surface. In the, if you look at the shaping process, and we are having the tool here. Okay, so this is the transient surface, you know this is the transient surface. Okay, so here is going to act the FT. There are the two components of FT, or you can take like this is FT. So it is having two components. One is normal to the surface, Fn, and one is axial to the surface. Okay, and tangential component, this is the FC. So FC, this F फीड फोर्स बोलो आप इसको, या एक्सियल बोलो, एफ एंड एफ एन. So these three components they are asking. Okay, so try to solve this question. Very easy again, no any big deal. Only the thing is that shaping you have to know this is the oblique cutting operation. You have to convert it into orthogonal operation. That is, T1 becomes, this is F cos of lambda, then B is equal to D divided by cos of lambda. Okay, these two things you have to take into account. Okay, and from the same we can have FC divided by Fs, that is equal to cos of beta minus alpha divided by cos of phi plus beta minus alpha. Then FC will get, and then finally FT is what? FC tan of beta minus alpha. Then from FT you will get two components. FF will be what? This FT cos of lambda, and Fn will be Ft sin lambda. This is how, this is the second component, this is third component, and this FC, this is the first component. Three component you can definitely easily get. First thing is that you have to convert this oblique cutting operation into orthogonal. Orthogonal cutting करना पड़ेगा, conversion होगा, isn't it? Like when you convert this turning to the orthogonal, this is also plane turning, you take it is oblique, we have to convert into orthogonal, then and then only analysis is possible. That you know very well. I hope you will solve this question very nicely. Tomorrow we will discuss the solution for this also if you want, but tomorrow I want to focus on to major part of the non-traditional machining and the advanced machining method, NC/CNC. Okay, so definitely there is a major areas, that is ECM and EDM only we can have the many chances to get the numerical. We'll discuss it tomorrow. Okay, so again these are the questions. Take these questions for the homework. This is a question on the taper turning. So this is a question on the taper turning. So this is the set over method they have used. Okay, so big diameter is how much? 75, small diameter is 60, and the entire length is how much? 100. Okay, set over method. And what is taper length? It is 45 mm. So they are asking the what is the set over? Set over is what? You know very well how to get the set over. So this is the set over that you know. So this is the S, this is suppose A, B, C. Okay, so this is alpha. So set over what? Sin alpha is equal to what? S upon length of the bar. So set over is equal to L sin alpha. That to get. And you know how to get taper. That is taper, how to calculate taper. So taper angle alpha is equal to what? D bigger minus D smaller divided by 2L. So definitely you can solve and get the values for this. This is also done. Yes, Amandik, same time. Okay, set over method generally for the long bars. Okay, you know very well. So this is the question regarding to the again power requirement per mm cube of the material remover. So power FCVC, you calculate it very nicely. Take this question as homework again, very easy, which is the intermittent feed for the shaper is given by the ratchet and Powell mechanism. So on that mechanism, this is the question on ratchet and Powell. Okay, if you are not getting, please ask me, we will solve this question, no issue. Okay, so dear students, I hope it is okay for you guys. So we try to cover the maximum parts of the metal cutting, major things I am saying. It is very big topic, it is very big topic dear. Directly you can get the questions like 2 marks, 6 marks questions. Okay, chalo le lo bhai, only numericals like this they can ask the questions on metal cutting. That is why I have taken so much types yesterday also and today also. We have kept the 2 sessions for metal cutting. The reason is same only, huge topic, we're having a very good weightage. So like that, the metal forming is the second topic dear, and that topic we are going to crack it on Tuesday and Wednesday. Be there Tuesday and Wednesday, coming Tuesday and Wednesday in the afternoon 2 p.m. 2 to 4, right? Okay, so you can go through this dear students. These are the courses launched by this Gear Up Super, Gear Up, Rank Up. Okay, but dear students, if you are in the second and third year right now, though definitely the Vision 2022 is excellent course dear students for the second and third year who are willing to write the exam in 2022 GATE as well as ESE. So go through the details. Any query, you just contact on the given number. You can find the faculties, very excellent faculties dear. Dheeraj sir, Rushi sir, Ankit sir, myself is there, Chandra sir, Harshit sir, Balaji sir, well known across the countries, right? These are our achievers. These are the subscription pricing dear students. Any query, you just go and contact the number, you will get all the details, what are the changes. Okay, definitely you will get all the information at that. So tomorrow again 7 p.m. don't miss NTM plus advanced or SIMS, computer integrated manufacturing system. Based on that, the tomorrow session, meet once again at 7 p.m. tomorrow. Till then, tata, bye bye, good night, take care, Jai Hind. And do follow me on the Gradeup app. Thank you so much.